Okay, so I'm going to go through the problems that you had that are on page 122. This is numbers 34 through 47, and I want to just make sure that you understand how to do them and that you heard how to do them, because some of them are easy and some of them are not. 34 is pretty easy, I think. First thing I would do is I would change both of those to give them exponents, so that's 3t to the negative 1 and then 4t to the negative 2. So if I find the derivative, use the power rule, so I would get negative 3t and then subtract 1, negative 2, minus 8t, subtract 1, so I get negative 3. Alright, on 35, the very first thing I would do is I would multiply everything by square root of theta. So when I multiply here, theta, square root of theta times square root of theta is the same as square root of theta squared, which is theta. Now, if for some reason you change those to powers first, that would be theta to the 1/2 times theta to the 1/2. If you add those exponents, you get 1. So that's why it's theta to the first. Then I'm going to multiply square root of theta times 1 over square root of theta. That comes out to be square root of theta over square root of theta, which is 1. Now, if you changed it to theta to the 1/2 and the other one to theta to the negative 1/2, when you add those exponents, you get theta to the 0. Anything to the 0 power is 1, so that's why we get a 1 there. Now, that's not the answer, because after that I need to find the derivative. Think of this as like x. The derivative of x is still 1 because there's a number in front of it. Derivative of 1 is 0, and so that it stays by itself. First thing I would do is I would divide each of those by x. Now the way I do it is like x squared over x and then 1 over x. I have seen some of you rewrite it like this with x to the negative 1 coming up top. That is okay, just be really, really careful, and remember that when it comes to the top, that you have to multiply it by the top. So then you would do that times that, that times that. Either way, whether you divide it or bring it up and multiply it, it's the same. You still would get x plus x to the negative 1. So once you find the derivative would be 1 minus x to the negative 2. Alright, 37. So again, I'm going to rewrite it as z squared over 3z plus 1 over 3z. If you do want to bring this one up and rewrite it, you're going to have to make it 1/3 z to the negative 1, because the 3 is on the bottom, so it could have a negative 1 power, but you don't know how to find the derivative when the 1/3 and the z have the negative 1 power. So I would leave it like that. And then either multiply it or simplify, whichever way is easier. You're going to get z over 3, or 1/3 z, plus 1/3 z to the negative 1. So then I find the derivative, and the derivative is 1/3 minus 1/3 z to the negative 2. Alright, 38. I'm going to go ahead and divide it. Again, it's okay if you want to bring it up. You still should get t to the negative 2 plus t to the negative 1 minus t to the negative 4. So now if I find the derivative, using the power rule, you get negative 2 to the negative 3 minus t to the negative 2 plus 4t to the negative 5. Okay, I'm going to go ahead and write the next one as theta over square root of theta. Again, you can bring it up. If you did that, it would be theta minus 1 times theta to the 1/2, and then you could solve it for there. Basically, this will give you theta to the 1/2, because this is 1 minus the half power from the square root, minus theta to the negative a half. So then if I find the derivative, it would be 1/2 theta to the negative a half plus 1/2 theta, subtract 1, minus 3/2. So, number 40. This one's different because there's a whole bunch of letters. Remember that all the letters are a number except for the x. The x is the variable. So if I'm going to rewrite this at all, the only thing I would probably do is rewrite it as, make that 1 over a, so it's easier to think about like the x being separated. So now when I find the derivative, it's 3 times 1 over a, or 3 over a, x squared, plus 2 times a over b, so 2a over b, x, and then the derivative of c squared is 0, so that part's not there. 41. I'm going to rewrite it, ax over x plus b over x. If you bring it up, that's okay. I didn't rewrite that, so that should be a plus bx to the negative 1. X is our variable, so the derivative of a is 0, and then I do this like normal. B times negative 1 is negative b, and then subtract 1 on the power. Okay, 42 is similar, except the x is not on the bottom, so that changes things just a little bit. I'm going to put them both over c. And then I'm just going to rewrite it as a over cx plus b over c. I personally like to do this one this way since the x is not on bottom, and since I don't need to subtract anything with those exponents. I think it's easier to figure out what the derivative is, but you can do it how you want. The derivative of a number, because a over c is a number, times x is the number. The derivative of b over c is 0 because b and c are both numbers. It is okay if you write a c to the negative 1. If you do it that way, you still might have it written that way instead. 43. So on this one, I'm going to have to multiply out the top and then divide it by the t squared. If I multiply out the top, I get square root of t times 1, which is square root of t, or t to the 1/2. Then if I do the square root of t times t, that's t to the 1/2 times t, so that's t to the 3/2, and then divide them both by t squared. So then I'm not ready for the derivative yet. So subtract those exponents. So 1/2 minus 2 is negative 3/2. 3/2 minus 2 is negative 1/2. Then I find the derivative finally, and I get negative 3/2 t to the negative 5/2 because it's subtracting 1, minus 1/2 t to the negative 3/2. Okay, 44. Okay, this means find the derivative of v with respect to r. So that's telling me that r is a variable. So when I look at v equals 4/3 pi r squared b, if it were me, I would probably take that r and like put it separately. Like I would probably rewrite it as 4/3 pi b, because all of that's a number, times r squared. So then to find the derivative, I know I'm going to do 2 times all of that, which is 8/3 pi b times r, and then subtract 1, so it's just to the first power. 45. It says to find dw dq. dq is my variable, So when I write this W equals, I'm probably just going to put all my little letters together. I know that's all a number times Q. So if I find the derivative of W with respect to Q, all of this is a number times Q, so it's just the number. .46 is not too difficult. It's already written kind of nicely. So the derivative here, since x is my variable, is 2ax plus b, and the derivative of c is 0, so nothing else there. And lastly, p equals a plus b square root of t. So I know that t is my variable, so I could write this as t to the 1/2. So now if I find the derivative of a is 0, because it's a number. The derivative of this part, it'd be 1/2 times b, or b over 2, and then subtract 1 on the exponent, so t to the -1/2.